In this video, we're going to look at adding and subtracting radical expressions. In order to add and subtract any two quantities in math, keep in mind that they have to be like terms. So the variables have to match, and then you can combine them by combining their coefficients. We want to keep that in mind as we look at radical expressions. So first, let's define what is a like radical expression, or what are like radical expressions, since it has to be like something else. Well, like radical expressions, those are expressions that have the same radicand and the same index. So these would be like radical expressions are radical expressions with the same radicand. Remember the radicand, that's what's underneath the radical, what's inside the radical, and the same index. And then in order to be able to combine two radical expressions, not only must they have the same radicand and the same index, but also if there's any variable in front of the radical, the variables would have to match. So if we have b radical 3 and b squared radical 3, we can't actually combine those, right? If we have, I said b radical 3 and b squared radical 3, while they do have like radicals, they're not like terms in general because this one has a coefficient of 1b and this one has a coefficient of 1b squared. We can't add b to b squared, so we would not be able to further combine those. So that's when we're going to combine them, they have to have the same variable parts in front, the same index, and the same radicand. Let's take a look at some examples. Letter A, we have 3 radical 7 minus 8 radical 7. So they are like radicals. They have the same radicand of 7, and they have the same index. One's not given, so it's assumed that it's an index of 2. When we go to combine these, we combine the coefficients. So we're going to do 3 minus 8 radical 7 is -5, so it's -5 radical 7. Next in letter B, we have 5b radical A plus 3b radical A. So they are like radical expressions because they both have a radicand of A and an index of 2. And we can also combine them because we have a B and a B, so that's good. So what we're looking at is we're looking at adding 5 plus 3, and then the variable part and the radical part would be b radical A. Well, 5 plus 3 is 8, so we have 8b radical A as our final answer for letter B. Letter C, we have 6x times radical 10 minus the square root of 10x squared. Right now, they are not like radicals. What we might need to do is we might need to see if we can simplify one or both and then see if they become like radicals. The square root of 10 does not have any perfect square factors besides 1, so we can't simplify this at all. But 10x squared, x squared has a perfect square, it is a perfect square, and its root is x. So we're going to factor, or we're going to take the square root of x squared and pull an x out of the radical. So it's going to give us 6x radical 10 minus x radical 10. And I'm sure somewhere it does say that x is going to be positive. Great. Okay. Now we have the same, look, we have like radicals, root 10 and root 10. And then we also have x's as part of the coefficients of our radicals. So this is like looking at 6 minus 1, x root 10. 6 minus 1 is 5. So we end up with 5x radical 10. Letter D, we have 6 times the cubed root of 4 minus 11 times the cubed root of 32 plus 7 times the cubed root of 4. We see here we do have like radical expressions. We have the cubed root of 4 and the cubed root of 4. The middle one isn't a like radical expression yet. Let's simplify it and see if it can join the cubed root of 4 radical family. So this one, 32, does it have any perfect cube factors? 8 is a perfect cube, and it's a factor of 32. So this 32 could be 8 times 4. And then if we were to take the cubed root of what we can take the cubed root of, we would have, I'm just going to rewrite the first term, minus the cubed root of 8 is 2, so a 2 pops out and joins the 11. 2 times 11 is 22. 22 radical, cubed root of radical 4, plus 7 times the cubed root of 4. And now we do have 3 terms that all are like radical terms. So we add the coefficients. 6 minus 22 plus 7 times the cubed root of 4. And that would be 6 minus 22 is negative 16 plus 7 is negative 9 times the cubed root of 4. That would be our final end result for letter D. Moving on to letter E here we have the fifth root of 3b plus the cubed root of 3b. So we do have the same radicand, however, we do not have the same index. We cannot combine these. So this would just, we can say cannot be combined, or you could just leave it as is, cannot be combined. But because they don't have the same index, we cannot combine them. That was one of the two things we needed. We needed the same radical expression, the same radicand, and we needed the same index. Lastly, letter F, we have negative 15 times the cubed root of 81 plus 3 times the cubed root of 24. They're good with the index. They're both index 3, but they don't have the same radicand. So we do want to try to simplify one or both of them. 81 has a perfect cube factor. 27 goes into 81, and it's 27 times 3. So the cubed root of 27 is 3, which means a 3 pops out of the radical. 3 times negative 15 is negative 45. So we have negative 45 times the cubed root of, and what's left under the radical is that other 3, the other factor from 27. Then we have the 3 times the cubed root of 24. 24 has a perfect cube factor of 8, and it's 8 times 3. The cubed root of 8 is 2, so a 2 pops out. 2 joins the 3, so that becomes a 6. And we have the cubed root of 3 left under the, or as our second piece of that. We can combine these now because they do have the same radicand and the same index. Negative 45 plus 6 is negative 39 times the cubed root of radical 3. It's important to note that when the radical does have an index besides that square root, so when it's 3 or 4 or 5, you do need to keep bringing down that index. If you remove the index, you're turning into a square root, you're changing the problem, and it will be wrong.